So welcome, everyone. I am surprised to see that many of you in a presentation about variance modifiers. Not because it's not an important topic. It is an important topic. I believe that most of you, if not all of you, are using variance modifiers and benefiting them on a daily basis. You just don't know about it yet. It is because it's not a cool and trendy topic. Just the opposite. What I will present to you is a modern standard, or even, I could say, a scientific agreement for how languages, how variance in generic systems should be designed. What I will present to you is present in many languages, many modern and civilized languages, like Scala, C#, also some less civilized languages, like Dart. It's also partially implemented in Java or Swift. And in all the languages that do not have it, I believe they do not have it not because they wouldn't benefit for that. They would benefit from that. It's because it's just not yet implemented there, okay? So a modern standard and a very universal knowledge that I think every experienced developer should have. So a word about me. My name is Marcin Moskała. I am a consultant, a trainer, a contractor, an author of a couple of books, including Kotlin Coroutines Deep Dive, which is very well known right now, and Effective Kotlin. But this workshop is related to my book, Advanced Kotlin. This is where I explain the most advanced Kotlin features, including generic variance modifiers, delegation patterns, and all the meta-programming like reflection, KSP, compiler plugins. I also present that on my workshop, Kotlin Expert, so all that in 2 days. What is the plan for this workshop? I will first show you what are generic type modifiers. Then I will show you why do we use them, where do we use them, what are they used for. And then I will show you some limitations, which will also explain to you how they should be used and how they shouldn't be used. Just to make it clear, at this point, I assume that all of you understand basics of generic type parameters, like this T in here, in functions, declares the relationship between parameters and the result. In classes or interfaces, allows us to define a type that determines the parameters and results of methods. What I assume might be is what you are interested in, is to learn what are in and out modifiers. And in and out modifiers, also known as covariance and contravariance, answer to the question, what is the relationship? If int is a subtype of number, what is the relationship between box of int and box of number? Okay? By default, if you use no variance modifier, we are dealing with invariance, so there is no relationship whatsoever. If you use covariance, which is out modifier, there is the same direction of relationship. So if int is a subtype of number, box of int is a subtype of a box of number. If you use contravariance, the in modifier, the reversed relationship. So let's see it in practice. We have box of t, we have a bunch of types, boxes, no relationship between them whatsoever. That means you cannot use them, you cannot use box of puppy as a box of dog, or box of dog as a box of puppy. No way to use it this way. However, if you use covariance, you use the out modifier, then if you have a relationship of types, there is an analogous relationship of box types. Yeah? So box of puppy is a subtype of box of dog. That is why you can use a box of puppy as a box of dog, but not the other way around. Of course, you cannot use box of dog as a box of puppy. Just like you cannot use puppy. You can use puppy as a dog, but not dog as a puppy. And contravariance is reversing that. In modifier, notice that arrows go to the other direction. So box of any is now a subtype of all the types, not a supertype. And so the opposite is true. You can use box of dog as a box of puppy, but not box of puppy as a box of dog. Variance can be used on 2 positions, either in the declaration side, which means using it at the all use side by default, or at the use side, which is like specifically for one use. Java only has use side variance modifiers, which are implemented with super and extends. Kotlin has declaration side, which is much more powerful and much more common. At this point, many people ask me about what if I want like to have it both. Like I have like invariance, which is just type, covariance, which is type, and it's type or its subtypes, contravariance type, and its super types. What if I have both? If you would have both, then you could go from any type to any type, yeah, which is kind of a nonsense for a declaration side. It makes sense for a use side, and it is called star projection. Yeah, this star in here means accept absolutely everything, which is like just like both of them. Okay, so this is the theory, and being you sitting here and listening that for the first time, I would probably wonder, but what the hell do I use it for? What are use cases for those variance modifiers? So let me show you some basic examples. Imagine that you are an animal lover. You have a hierarchy of animals. And since you love animals and you go back home, you are petting all your animals, so you have a function to pet all your animals. Yeah? Pet animals gets list of your animals that you can use to pet them. But at the moment, you only have cats. So you have a list of cat. List of cat is inferred in here. The question is, can you use list of cat as a list of animal? Can you? I mean, in Java and in most programming languages, you cannot. But in Kotlin, you actually can. There are two reasons behind it. One is, of course, that Kotlin supports variance modifiers. And the second one is that Kotlin separates read-only and mutable collections. Yeah? List is a read-only collection. That's why it can be covariant. It can have out modifier. Yes? List is read-only, meaning it's not accepting any E, okay? It is only exposing it, it only goes out. And so out modifier, the covariance, is appropriate here. For everything that is immutable, that is produced, that is only exposed out, out modifier, the covariance modifier, is appropriate, and it is appropriate for a list. And because of that, as I told you, list of cat is a list of animal, because cat is a subtype of animal, and we are having covariance modifier. It wouldn't be true if we used mutable list instead of a list. Now it is impossible to use it. And then now I ask the question why, and there are two answers. Very simple answer is because mutable list is contravariant, it has no variance modifier, but why is it contravariant? There is a very simple and logical explanation. I will present it entirely in the last section, but for now, just imagine what would happen if I had a mutable list. I added a different animal, like a dog. It's an animal, so I can do that. Now, if I would ask for a last cat, I would receive a very, very strange cat. Yeah? That's why it is illegal for mutable collections. But for read-only collections, it is perfectly fine. Does it make sense? Okay. Now, another example. Let's say an opposite example. Imagine that you are sending messages. So you have a sender of messages, and you have two sets of messages to two different services where you send your messages to. Your order manager message and invoice manager messages. But to send those messages, you defined only one class, because that can be universal. You just take messages, you serialize them, and you send them. So you don't need to do a separate sender for different kind of queues. You just need to have a different URL. However, when you are having the actual sender that you want to use, you don't want it to be a sender of message. You want it to be a sender of specific type of message, like order manager message or invoice manager message, to not send an incorrect message a message to an incorrect receiver. Does that make sense? So the question is, can you do that? The answer is, by default, no, because of what I told you at the beginning. The default variance in Kotlin is the invariance. So there is no relationship between sender of order manager messages and sender of message whatsoever. However, you can achieve such relationship if you use contravariance, the in modifier. And here another example of a proper usage of variance modifier. In is for things that are coming in. If you are just consuming something here, consuming the message to send it, in is perfectly appropriate. Okay? So this actually makes this code works, and this makes sender interface more appropriate. Okay, another feature, another example, this time related to function types, something that we like very much in Kotlin. Imagine that you have a function that needs to consume another function, like a function from int to any, because it's consuming int and printing it so it can produce anything. But you do not have such function reference under your hand. Instead, you have a function from int to int. So the question is, can you use it? The answer is yes, you can. You can use it, which kind of makes sense. This function will receive an int. That's fine. I expect an int. This function should produce any. It produces int, but int is a subtype of any. It kind of makes sense. Another example, can you use a function from number to double? This is where people start being unsure, because those are two totally different types. Like number is not an int, double is not any. However, it also works perfectly fine, because this function will be fed with an int. It expects number, that's fine. It will produce double. We expect it to produce any. That's fine. Another example, from any to string, it will also work perfectly fine. I drew today morning this beautiful picture for you to visualize it. When you have a function type, the parameter type, the in type can be much wider, because whatever comes into it still will, be accepted. It's still within the range of what we expect. But the outer type, the out type, the result type, it can be more narrow than what is expected of it, because it will still fit into the next step of the flow. To put it from a different angle, I draw this hierarchy of random function types, and notice the relationship between them. If you, for instance, take the parameter type and go down, you go from int to number to any. So as you go down, you have an upper type. So reverse relationship in modifier, contravariance, yeah? But if you take a look at the result type, you go down from any to number to int. So as you go down, a more specific type. So the same relationship, yeah? So quite clear out modifier covariance. That's what it is under the hood. Under the hood, function types in Kotlin use in modifier for all parameters and out for all the results. So this leads us to a very important pattern that I could see in many places in Kotlin, also in standard library, in at least a couple of places. I could also see it in other languages, but weird thing is that I couldn't find any name. It wasn't named, so I named it myself. Covariant Nothing Object is a name that I gave it, and I can see it already starts popularizing. So what is Covariant Nothing Object? Let's start with a simple example. Imagine that you want to define a hierarchy of messages. If you define it this way, you will have a warning on IntelliJ or Android Studio. Warning will tell you that here you have a class, stop scanning, that has no values inside of it. So it should rather be an object. Yeah, quite a clear thing. When we define the sealed hierarchies, we define objects, typically data objects, over there. The same applies to generic types. When you define a generic type, like a linked list in here, you would prefer to have object. Yeah? So we have node, which keeps some value, so it must be a data class. But you also have this empty, which doesn't keep any values. So we would prefer it to be an object, yes? To not create a new instance every time we need another one. So yeah, this is that. So we want it to be an object, to not create a new instance every single time. However, if you just make it an object, or even data object, Kotlin will tell you that object cannot be generic. So what to do with that? And that's the trick. You can use nothing as a placeholder type, and to make it work, you need to use covariance. Covariance is appropriate here because it's a read-only type. It is only for exposing things. If you have something immutable, covariance is generally perfectly applicable. And then linked list of nothing, since nothing is a subtype of all the types. Linked list of nothing is a subtype of all the linked lists. So linked list of nothing is a subtype of linked list of string, a linked list of int, and any other possible linked list. A practical application of that is an empty list or a list of. If you use a list of from Kotlin standard library, under the hood it calls linked list, empty list. An empty list, as you can see, references to an object. Yeah, it's from uppercase, so that's quite clearly an object. This is internal object, and as you can see, this object is a list of nothing. So it means that absolutely every empty list in your application under the hood is exactly the same instance, is the same list of nothing, and it can serve as a list of users, as a list of products, as a list of tags, whatever you use. It's very likely that in your application right now there are thousands of empty lists produced per second, and thanks to this optimization, you are not creating new objects for every single one of them. It's the same object for everyone. Okay? So that is the pattern. Of course, it applies to other collections as well, and some other types as well. Another implementation of this pattern is related to a library that we made in one company. It was internal library. Imagine that you have some task that you want to, that has some properties, and you want to configure that. We had a need to define a class that is defining how those tasks should be modified. And the classic Java pattern will be doing something like that, using some update, which uses null to mark do not change this value. Well, that's not a good approach. First of all, because if null is used as a marker for a lack of value, how can you set null? That's an unresolved problem. How can you set other kinds of messages, like update, or use something from before, or use set default, or something else? There are no easy ways to do that. I mean, you can use some markers for that, but then you are even more losing type safety in your object. So this is not a good pattern. So what we used instead, I know it's a bit small, but essentially that's a small hierarchy of types. There is a task property update, which has two subtypes, either keep or change to. We actually have more subtypes, like something like set default or restart or whatever. You can have huge hierarchies of what different properties can allow others to do and what not. And then your update is just a bunch of wrappers that by default are to keep. And so then update can be created that easily. In general, another example of that, but this is a slight modification of this pattern. I call it Covariant Nothing Class. This, of course, will relate to the arrow library. You probably know it pretty well. And there are sometimes classes that are representing something like either or, yeah, either left or right in arrow. And such an implementation would be probably the implementation that an average developer would produce. But this is not a good implementation for at least a couple of reasons. But the simplest one is that you cannot create right without knowing about the type of left. And you cannot create left without specifying a type for right, which is a nonsense. A better implementation looks like that. I see variance is missing. Oh, yes, one more slide. The better implementation looks like that. We make our type parameters covariant, and we use nothing as a placeholder for lack of type. This way, left only specify left type, right only specifies right type, and you can use, for instance, left of string as either of string or an int, or either of string and throwable, or either string and whatever else, any, okay? Because nothing is a subtype of every type. So that's the power of covariance. And this is how it is implemented in Arrow. It's a good library. And it, of course, gives us much more advantages and much more flexibility in those types management. Okay, in general, if you have a sealed class hierarchy that must be generic, of course, the data classes that wrap values that use this type, they are quite clear. They must use, they must specify this type and use it. But about the types that are not holding any data, like here, clear Q, which is not keeping anything, it's just this label message. You can use nothing as a placeholder for a lack of value, and it works perfectly fine if you make your generic type covariant. And this is Covariant Nothing Object pattern. It is especially useful if you want to have markers for either a value or a different value, and no value, or something like that. Here's an optional value implementation. That's the most type-safe, not the most efficient, but the most type-safe optional value implementation. Of course, in Kotlin we are using nullable types or results for that, but that's what you could use if we haven't got that feature built into language. Okay, at this point, I should move into the limitations. What are the limitations of those variance modifiers? That should also explain to you how variance modifiers should be used and how they shouldn't be used. I would like to start with 3 lines that break Java code. You see, I did that, being a Java developer. I guess like 14 years ago or something. If you make an array of, let's say, integers in Java, you can upcast it as an array of objects. Because arrays is the only type in Java that is covariant by default. It's covariant. Which is quite funny because it shouldn't be covariant, because it is mutable. Yeah? And so if you then try to modify those objects by, let's say, specifying a string at some position, boom, that will throw array store exception. You're trying to put a string where integer is expected. You cannot do that in Kotlin, because in Kotlin, arrays are invariant. They have no variance modifier, which is correct. Okay, you can only do that in Java. But it shows us the essential problems with covariance. So to understand it deeply, we must first understand what is an in position and out position. So in position is everything that comes into a function, a parameter, basically. And what is important is that at this position, you might give not only a specific type, but also as subtypes, yeah? Because any type can be upcasted into this type. So it can be a dog, but it can also be a puppy or a hound. That's the opposite from the out position, the result of a function. Since we are at the other end of the function, when we receive a dog, we can upcast it into wild or animal or any. So we can go up with it. And when you see those pictures, that probably corresponds in your head with the pictures I draw about covariance and contravariance. Because imagine that you make a box that is covariant, so has out modifier, and has in position. That doesn't work well, because, here is an example, because you could make a box of dog, upcast it to a box of animal, yeah, covariance allows you to do that, and then put any other animal into it, like a human. Yeah. I don't know if you know about it, there was a presentation about ethics before this one, and that's one thing that you shouldn't do in programming. You shouldn't put humans into dog boxes, yeah, that's not appropriate. But in general, you could take any type, upcast it to this type of any, and put absolutely anything inside, which must fail, okay? It just cannot be right. So in general, that would fail. In general, that is illegal. If you try to use covariance at the in position, so either parameter or a public in position or a public property, with a setter, then it will tell you that you cannot do that. It is fine if you make it private. Private is fine because it's kind of inside of the class. You cannot upcast this class. Yeah, you are already the class is already clear and ensured. I don't know how to say it, but you just can have no movement, and you cannot make the trick I mentioned a moment ago. And so private is fine, but you cannot have such public positions, meaning that out must go out, so it can only be produced. It's only used for things that are going out, perfect for immutable, for producers, for this kind of classes. And the opposite problem. Imagine that you have a box that is contravariant, the in modifier. So, and you have a type at the public out position. Again, that's the co-problem, the reverse problem, yeah? If you take everything that I just discussed and reverse it, it's in an appropriate way, it is the same problem. So if you take a box with an animal, you upcast it as a box of dog, and you try to get something out of it, you might expect it to be wild, yeah, which is of course not possible. Again, in general, you could take a box of anything, upcast it into box of nothing or type of nothing, and expect it to produce absolutely anything. We just cannot work. Can you see the point? It's like in and out modifier and in and out positions. They go to the same direction. So covariance and in positions are up, and it works fine, but up and down. And the opposite with contravariance, and down, but it's fine, but down and up. So that's the point of it. So again, this is illegal, of course, at the public positions, so making them private helps. So in is appropriate for the things that are consumed, that are coming in, that are like this, message sender. That was a good example of a covariant type. Okay, and of course, every rule has its exceptions. There is a very famous exception for contravariance. I told you that for covariance. List is covariant, so it has out modifier, which means that its type can only be used at the out positions. But what about contains? That's quite clearly an in position, yeah? So it should be illegal. And well, it is illegal, but the list interface uses this special annotation and say variance, which is quietening our restrictions, yeah? Let me just show you. Without this annotation, that actually is not very useful. In this case, without these restrictions, without this annotation, I cannot do that. With this annotation, I can cheat. So it's like, I know what I do, trust me, it's fine. And it is fine, because contains is not actually using this type, it's only comparing it, so using equality, which is a property of any object, so it is safe in this regard. But when you use unsafe variance, think twice if this doesn't, if it isn't going to cause some troubles. Okay. As I said, if you want to learn more about it, there is a whole chapter in the book, Advanced Kotlin. I also conduct a workshop about it, 2 days, where with the groups. There is an open edition at the end of the year, and I also conduct it for companies. Companies have budgets, and these budgets can be used to buy workshops. So then I come, or I conduct online, and teach such things, including KSP, compiler plugins, and reflection, fun thing. So that was everything from my side. Thank you for your attention. I guess there will be questions right now. I will just tell you, I actually have 12 minutes. It's fine. I also will tell you that I will, after the presentation, go out and make a small contest. You will play a game, compose game or collection processing game. I will explain everything. They also have a card. And the rewards, the price of this contest will be books. So they are all winnable to be. I want to give them away. So that will be during the break. But before that, do you have any questions? About anything, not necessarily. You can ask about coroutines, my workshops. Oh, go ahead, Xavier. I can hear you, but others not. And I guess it's not recorded. But
in a word? Yeah, OK, cool. First, thanks a lot for the talk. Very interesting. I was curious. I'm not sure if this might be useful, but could you have a generic like T, or a generic where you say, OK, I want, when it's in, I want it to be anything that matches this type, but when it's out, I want it to match another type, and that you have a hierarchy of of types, and you want to kind of have both in and out variants on the same generic. Is it possible with different constraints?
I was thinking. I mean, it's for one type. I mean, with different constraints. Do you mean in different situations?
Yeah. So, like for instance, the list. I know that the things I'm going to put in the list are going to be anything that is going to be like an in something, and the out is going to be something else, but it's the same.
Yeah.
I'm just wondering if there is a way, or if even there is a use case for that.
I'm not sure if this is what you mean, but what it sounds to me like main repetition is a use side variance. So I told you, for instance, that mutable objects cannot be upcasted, and mutable collections cannot be upcasted because they are contravariant. But at the use side, we can say that they are out. Now, mutable is in general is invariant, has no variance modifier, but this particular one is covariant. However, because of that, you cannot put things in. Why can't you put things in? Because the type that we expect is nothing. Because for the in positions, to make it safe, we must go into the lowest possible type. There is also the opposite true. I mean, this is actually something that I have seen in some projects, so it might be useful. The opposite I have never seen in any project, but it's theoretically possible, is to make it contravariant. In such a case, you can read objects out of it. You can add objects to that, yeah? But when you read something, like here I get an animal, let's just use first or something, the result is the highest possible type, which is an inalienable. And that's the use side. And of course, this is supported on Java. It's super and extends.
OK, thank you.
Thank you. And ask me anything. It can be absolutely non-talk related. Anyone? You're still thinking about it. I see people using their hands, so that's good. That's good. Yeah. Okay. I don't want to keep you here. I will be at the break. If you want to talk with me about anything, please. Oh, one more thing that I might tell you. I'm also right now working on something big. It will be a big workshop, but we are not announcing it yet. But soon it will be announced on my socials. I am very active on socials, so if you use Twitter or LinkedIn and you want to have some good quality tweets about Compose and coroutines and Kotlin in general, then find me. It's Marcin Moskala. Yeah, it's just like that. OK. So thank you. Have a nice day.